for this challenge or not when we are submitting it?
That's a good question. I think that you have to use Sepolia, unfortunately, because of the way that it scrapes the contract. And we use a certain key, I think, but you could try. You could try. It might work. But I think if not, use Sepolia. And if you need ETH, just let me know. I have like a lot of Sepolia ETH, so I have lots of access to that stuff. So okay. I can't see the chat window for some reason. When I hide the meeting controls, they go away. So, any other questions?
Good.
No? Good. Okay, cool. So, at least you guys saw how I did challenge zero. Go ahead and take a stab at challenge. You're not going to need to do challenge one tonight. Okay, tonight, uh, I want you guys to focus on Solidity, and the reason why is because like that's really the backbone to like everything that you do on the Ethereum blockchain, right? And it's the most important thing because it is the security layer of your application, right? That's always important to remember. It's the security layer. It's where all the funds are. It's where all of the logic is for your application. And so it's very important that you spend a lot of time on Solidity at the beginning of building your application and don't worry as much about the front end stuff. We're going to be talking really briefly. So I basically have 20 minutes. So what I want to do is talk to you guys about where you can go to get the information you need when it comes to Solidity, and then explain a little bit about I guess like we'll try to build something. I don't know if we're gonna have time. We'll try to build like a basic bank or something, but really like the concepts of Solidity and what you should build versus what you can build. So the general idea, you're going to be focused here today on this kind of like writing the Solidity source code. Okay. So essentially what happens is you write source code, right? And that is in Solidity, or it might be in Viper if you're writing in Viper, but it's the same thing. It's a high level language, right, that you're writing. It's compiled down using Hardhat and using Sol-C, a Solidity compiler, into bytecode. And then that bytecode is deployed to the blockchain, right? When it's compiled, the application generates an ABI, application binary interface. And it's kind of like the map to your bytecode. Because when it's compiled down into bytecode, it's not human readable. Like you can't read it unless you're like some kind of genius or something. It's literally just hexadecimal code. So the ABI kind of allows you to understand how the bytecode is read and written. And so that's why Scaffold ETH is so important because it reads in that ABI and it automatically allows you to interact with your application in the front end using Next.js. So that's with like the hooks and the components and the ABI and the debug contracts tab. So this is kind of like the development flow. The cool thing is Scaffold ETH just helps you focus on these two top things right here, right? Writing the front back end and writing the front end, right? And it kind of abstracts away the ABI and the bytecode stuff. So where do you go to learn? Solidity by example is the best place you can start because it has examples for like pretty much every example that you can think of, and all of the detailed documentation for Solidity. Well, at least some basic high-level examples of the documentation. There's obviously like documentation on the Solidity language website, but this is just a good place for learning. And if you look on here, there's a section with their YouTube right here, the Smart Contract Programmers YouTube, and he does very, very, very detailed explanations on all of the different examples. And so you can literally just go there and you can look at all of the videos that are available. There's actually like playlists for all the different functionalities. So like this is 32 videos all about Solidity. And then this is like another 171 videos all about Solidity 0.8. So there's a lot of cool content in here, and he's very like monotone and very explanatory on everything. So he makes good videos. And so the best way to learn is literally by just coming in here and grabbing things and putting them into your app. So I just would really recommend you guys go down the list and start reading through each thing. So the very first one is like a hello world. Like how do you just do a basic string, and how do you display that string in your smart contract as a value, and then stuff like that. There's also an app that shows you how to count things up and down. So the counter, and then there is the primitive data types section, which is uh, primitive data types is like what kind of data that you can store on the blockchain. So you can store booleans, which are true or false. You can sign integers and unsigned integers, which are basically like a certain limited size of bytes of a integer that can be stored. You can store addresses, which are basically also bytes, but they're stored in a certain amount of length for optimization on the Ethereum blockchain. So you can store addresses. And so that you can see here, there's just these cool examples that you can literally just copy into your application. So let's just do that real quick. Let me just set up an environment real quick. So I'm going to do npx create -e at latest. So this is the same command that Austin ran yesterday, which is going to spin up scaffold.eth in a directory that you choose. I'm going to call it Solidity testing or something like that. I'm going to choose hard hat as my chain. You can use Foundry, but I'd recommend using hard hat just because it's got better documentation. Um, really up to you. Okay, so we'll give that a second. So what we want to do is we want to take some examples from here and just put them into scaffold.eth, okay? So while that's doing that, let me do the same thing I always do. Let me split up my window. So I'm going to go into the Solidity testing folder, Solidity testing folder, and come over here. Okay, it's almost done. And so, yeah, read through these and kind of understand how those work. Okay, there we go. So Solidity testing. Okay, so now I have this new environment set up. So it's the same thing I did earlier. You're going to get really good at this. Yarn chain for our backend, yarn start for our front end, and yarn deploy for the actual deployment. Oh, I need to shut down my old chain. Hold on a second. So I need to set down my other one that I was doing. So let me do that again. So if you saw what happened is I spun up the front end on 3001, and then it was complaining that hard hat was already in use, the port. So there we go. Okay, now let me do a deploy again. Now I'm doing a deploy -- reset, which just forces a new contract. I think probably Austin already showed that. Okay, so now we have an environment of scaffolding set up. So let's load it up again. So this time it will be different because it's just the normal scaffolding. That's not the NFT challenge, right? So it's compiling right now. There it goes. Okay. So let me disconnect from MetaMask because we just want to use the burner wallet. There we go. Okay. So what I want to show you guys is, first of all, let me load up the code and let me go into the hard hat folder. So when we load up packages, hard hat, contracts, same thing. We have the contract here and we have the deploy script right below it, right? What I always recommend doing is just coming here and just starting with a very basic contract. So I just like erase everything essentially. I literally just erase everything inside so that I have an empty contract like this and save it. That's it. So I keep the hard hat console because it's very useful for debugging. I keep this because I might eventually want to use Open Zeppelin's ownable here, but I just wipe out this contract. I just blank it out. Then I just redo a deploy. It's going to give me an error, but I want to walk you guys through the error. It's going to tell me that, well, you're trying to deploy something, but you're passing in some arguments that you're not supposed to be passing. And that's because our deploy script, which is right below it, is passing in a address, the deployer address. Okay. So I just need to get rid of this. So these are the contract constructor arguments. So when you deploy a contract for the first time, you deploy the constructor. Okay. So the constructor can be empty. It doesn't need anything in there. But if you want to set a variable at the very, 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 very first time that you deploy a contract, that's where you should put it. Or if you want to do something, some logic, like call a function or anything you want to do, you throw it in that constructor. But it can be empty. And so because before we were passing in a address in here like this, we were passing in an address. Well, we got rid of that. So we don't want to pass anything anymore. So we need to just delete this from this arguments here. Okay. Um, does that make sense? Hopefully that makes sense. This is the deploy script for our contract. And so this deploy script, let me just get rid of some of this comments so it's easier to understand what's going on. But basically, we also need to get rid of that, which I'll explain in a second, but I'll walk you through it. So here we're getting a copy of the contract. Here we're getting a deployer account from Hard Hat, which is like one of those private keys. Remember, I told you that we have all those private keys that are in Hard Hat. Well, this is grabbing the very first one, and it's using that as the person that signs the transaction to create the contract. So the way that you deploy a contract on the Ethereum blockchain is you send a transaction with all of the bytecode. And so that's what this is doing, is it's sending the entire contract's address, the contents of the contract as bytecode from the deployer account. And that will create an instance of a contract. It basically writes it to the blockchain. And during that, you can pass arguments. We're going to get rid of those. And then these are just some settings. These could be disabled or enabled. They're not important. And then here in the script, we also get a copy of the contract so that we can interact with it. So this const variable allows me to say, well, here's my contract. Get it from the name your contract, which is here, and allow me to interact with it. And so you'll see here that there was a call made to .greeting. Now, if I save this and try to deploy now, it's going to fail again because we're trying to call this function that is not available. Greeting is not a function, right? Because I got rid of it. I deleted it, right? I deleted everything here. So then we just need to get rid of that so that it doesn't complain like this. Okay. I know that's a little weird, but you'll start to learn about that. The deploy script is a little sensitive. You just have to like massage it to do what you want it to do. So now it was successful. So we can see here that it was successful and it deployed with so much gas, and it also updated the types. Okay. So now we can come over here and look at the debug contracts tab, and you can see that it's a blank slate now. It doesn't have anything in there. This is good because now we can put what we want into the contract to test. So we only have a few more minutes. So let's just try to do like one basic smart contract. So let's do the first app. So let's say we wanted to grab the first app and grab all this stuff. So we can just copy that and paste it into here. So what does this have? It has an unsigned integer. It has a get function to get the count, and it has an increment to increment the count, and it has a decrement to decrement the count, right? So I can save that, now deploy again. And once that's done, that was successful. Now I can go back to scaffold ETH, and we should see those things pop up here. There it goes. So we have a count variable, and we have the getter function for it, and we have the ability to increment it. So let's get some funds from the faucet, and let's increment it. Increment, increment, increment. So we can increment that value, right? Or we can decrement, 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 decrement. It's working. What happens if we go negative? Anyone know? It's going to fail because this is an unsigned integer, right? It's only can have a positive value. So we might want to make this an integer instead. So let's do that. Let's change this to an integer. Integer. And I think that's it. Yeah. Now let's redeploy our changes again. So I made a small little change, right? So this is what you should do, is you should start getting familiar with Solidity, right? Come in here, understand how you define variables, understand how you write a function, how they return values, how you do a return, how you make it public. What if you want to make this payable? What if I want to receive some ETH on the increment? right? So maybe I need to make this payable. So first of all, let's see if we can go negative, can we? Yep, there we go. So now it's an integer. It's not an unsigned integer, so it gives us a negative value. So now we want to make it so that when people increase the value, they can also send some ETH. So how do we do that? Well, we need to make it payable. So public payable like this and learn about payable and how it can receive some funds. Let's deploy our change again. And now let's see that, oh, okay, we should be able to send value when we increment. Now we have a payable function. So not only can we pay or increase the value, but we can also pay some ETH. So let's pay, I don't know, 0.01 Ether and then convert it to Wei. I'm sure Austin showed you this, that you need to convert it to Wei. So we have that ability to do that. So now we can send. And so now the contract has some money in it, but now it's stuck because there's no way to get it out. So then learn how to write a function to withdraw funds from the contract. So it's kind of this game of like starting to think about what you want to build and then figuring out what variables you need to use, what mappings. Like let's say you want to keep track of a value for a specific address. Maybe that's a balance. So maybe that's this. So you can come in here and copy that and say, oh, well, maybe we want to actually keep track of the value that we have for a user balance right here, like this. And then when someone actually sends some value, maybe we need to add that to it, like this. So using what's it called? Copilot helps a lot because it starts to write it for you. You see, it just did that for me. Now it's going to say, well, let's create a balances address, and let's every time someone sends some value, increase what their balance is, and then let's add a function that allows us to withdraw, right? There we go. Now we're going to be able to withdraw that function. So, combination of reading the docs and reading the examples. Now we should be able to deploy this change and see if that works. So you do a lot of this kind of hopping back and forth between Solidity. So let's see if it works. Let's try to send some value there. Let's increment. Let's send, I don't know, 0.5 ETH. Send it. Cool. Now we have some ETH in the contract. So I should be able to get it out. What's my balance? Let's grab my address. Put our balance in here. Cool. I have a balance of half of an ETH. Can I get it out? Let's try it. All right, cool. It was successful. Nice. So I got my money back. So you see what you do is you come up with an idea, look at the examples, figure out what you need to write to do that, and then start kind of deploying and testing your contract. Okay. So now my balance should be 0, which it is. Cool. All right. So that was a little speed run of like Solidity stuff. But the homework for tonight is what I want you guys to do is come up with a concept. Okay. There's some examples in the Biddle Giddle curriculum that I basically will send here. Let me just send this in chat real quick. I recommend just coming up with an original idea and trying to write some Solidity. It could be something so simple like a book registry, a diary, like whatever. It doesn't matter. Just come up with a cool idea of something you want to do on the blockchain. It doesn't even have to make sense. And try to write the Solidity code to do it and try to use scaffold ETH. And that's your homework. That's one that cannot be graded. It's just on you. So if you decide to make a smart contract today, that's great. You test yourself and do something cool. If you don't, then you won't, learn anything more. So the more you put into it, the more you'll learn. Okay. Cool. What kind of questions do you guys have? Sorry that we didn't get enough time for a lot of questions, but I'm happy to hang out longer as well because I don't have anything right now.
Yes, don't hesitate if you have any question. I think Kevin is really efficient. Yeah.
Yeah. So there was a question here. I see like any ideas for the hackathon. Well, I think the best thing that you can do for a hackathon is providing an example DApp that should be on chain. So just think about like, oh, does it actually make sense to store this on chain? Is this something that provides value to the ecosystem if it's on chain? I always like to say like look at like traditional Web 2 applications and try to build those on Web 3 because that's actually what we need is we need people to have usage. So there's so many options there. Like there's so many mobile apps for the iPhone and that you could probably translate to Web3. Don't has to be every like feature complete, but try to think of an idea of something and replicate it on Web3. I think that's a huge win. Those are the ones that tend to take off. Thank you so much,
If
guys. I'm glad
needed,
that you,
if needed,
yeah,
at the end of the developer course, I can send you a lot of idea for hackathon because it's my specialty to get idea. So I can put a list and also send you a list of DApp that you can just test, like around 50 DApps really used in Web3. It's important to test the application in order to get some idea. So I can provide you a list for that.
awesome. Cool. So for tomorrow, we'll we'll try to write a smart contract. And then we'll also like maybe walk through a little bit of what challenge one looks like. And we'll try to use scaffold base tomorrow, which is a special build of scaffold ETH that is base compatible and built for base. But please, yeah, try to like write some kind of smart contract today, even if it's something super simple, and get it deployed successfully locally on your machine.
Great. Super. Everyone is happy. Yes, great. So don't hesitate if you have any question as well to put it on Discord. We have a couple of women available to reply, and like Kevin said, the team Better Girl is available on Telegram, and especially I put the link just above, but I will put it inside the email recap. Great. Thanks everyone for
For
today.
today
And ooh, okay. Sorry, my friend is just here. Uh, yeah. So see you tomorrow, and I will put the record link in 30 minutes, I guess.
And then Monday, did you have a question? I saw you put your hand up.
Uh, I don't know if someone Monday, did you have a question? Don't
I
hesitate.
saw a hand go up, but I didn't know if that was just like woo woo woo. Maybe it
Yes,
was just like, yeah, what's up?
yes.
Could have been any kind of
Thank you.
cool.
Bye bye,
All
and
right.
see you tomorrow.
You guys are awesome. I'll see you tomorrow. You guys
Yes.
have a good night, okay? Bye.
Thanks, bye.